Hi, John here. In this video we're going to look at how dam water and an elevation difference between the outlet and inlet sides of the dam. This difference in elevation is referred to as the head. The headwater is located upstream of the dam and the tailwater downstream. The dam separates the headwater and tailwater. Let's now have a look at how we generate electricity using a hydro dam. Water enters the penstocks through the main inlets. The water then travels down through the penstocks until reaching the hydroelectric turbines located within the powerhouse. As the water passes over each turbine runner, the runners rotate and we obtain mechanical energy. The mechanical energy from the turbine runners is passed to electrical generators, which are connected on common shafts. We have now converted the water's potential energy into electrical energy and can distribute this through a transformer and a high voltage national grid. To end the process, the water flows from the powerhouse through draft tubes until reaching the tailwater. The entire process is continuous, which leads to a constant and reliable form of power generation. Advantages: hydroelectric dam.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity: large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply.
The kinetic energy of flowing water is called hydroelectricity. Thus, the electric power that is generated is called hydroelectric power. Electricity is generated from flowing water at hydroelectric power plant. A high dam is constructed on one side of the reservoir to hold back the water. The generator house is at the base of the dam on its other side. Water flows down through pipes from near the top of the dam to generator house below. It strikes the blades of a water turbine with tremendous speed, making it rotate. The turbine rotates the shaft of a generator to which it is connected. This makes the generator produce electricity. In this way, the kinetic energy of flowing water is used to rotate the turbine, and the rotational kinetic energy is converted into electrical energy. It is not necessary to set up large dams for hydroelectric plants. Small hydroelectric plants can be set up to generate electricity from a few hundred kilowatts to thousands of megawatts. Such plants can use water diverted from a waterfall